Welcome, physics students, to Vectors. This is Mr. Stockbridge. We're going to do a fairly quick and dirty video on vectors and all different aspects of them. Just know that this will be a quick and dirty video. If my phone rings or computer chirps or anything, we're just going to try and roll with it. With that said, let's go ahead and dive in. First of all, we've talked about what vectors are from last week. They're any measurement that has both a magnitude and a direction. Different examples also from last week are displacement or velocity or acceleration. I don't remember if we talked too much about force as a vector, but force is going to be a vector that we do a lot of different things with coming up here soon. Those are your basic examples. Now on the screen here, we're going to start working with vectors conceptually. We're not going to get too deep into the numbers. This is a simulation provided by PhET out of the University of Colorado up at Boulder. It's a great tool. It is linked at the bottom of your textbook in chapter 3.3, but I'll provide the link a number of other places in the course as well. Now, let's go ahead and I'll give you just a super quick tour here because you'll be using different parts of this simulation for your assignments this week. I think our readings are going to be kind of on the medium to minimal side, and it's just a lot of practice that we're going to be focusing on this time around. Over here you have your different vector arrows. You can just pull these out onto the screen like so. When you do, the vector is labeled or named with the letter there, so this is D. The little arrow over it is a symbol that we haven't talked about yet. Whenever you see that kind of arrow, it represents the fact that this measurement, this object has got a vector on it. So both the size of the arrow and the direction of the arrow matter. Up here we've got some different measurements, and you can ignore these guys on the right. Actually, we're just going to go ahead and make them disappear for the moment so they don't distract, but we'll come back to them later. The first number here is the magnitude of your vector, and that represents the length of your arrow. And then here we have the angle, and basically that's which direction is your arrow pointed. Your vector always starts at the plane end of the tail here, and then you travel towards the arrow, the tip of the arrow. Quick note about directions. Directions can be a little bit goofy. In math, usually what happens is 0 degrees is in the positive x direction, just horizontal, flat positive. You can see it's 0. And then as you go up, you get to 90 degrees is straight up. And then as soon as you're between 90 and 180, you can just see what happens. Let me go ahead and go all the way around. Oh, it goes negative in this one. So anytime you have a vector that's pointed downward in this particular tool, it's going to be a negative number. In some other tools and lots of other applications, it'll go from 0 to 90 to 180, and then this will keep going up, and so we'll have 270 and then back around the circle to 360. But for this tool, it's going to be just 0 to positive 180 or 0 to negative 180. Okay, so we have our magnitude, we have our direction. We've talked about what the vector does. Now, as you drag it around, you can move the vector wherever you like it to be. If you grab the tip of the arrow, you can change its orientation, you can change the length. Now, whenever you change either the length or the direction of the vector, you're talking about a completely different vector than before. So as you work, please just be careful that you don't change things accidentally if that's not your goal. In addition to clicking and dragging, no, apparently we cannot just type our values in up there. That's a bummer. That would have been helpful. All right. Now, on your vector, one of the common things that we do, especially when we talk about accelerations or forces, is vectors can be combined with each other. So to show you that, I'm going to pull out another vector here. So here we have two different vectors. Let's just go, we'll go something like this. Whenever you add two vectors, what you're going to do is you're going to take your first vector, and there's the base, there's the tip. Vector addition is super simple. Basically all we're doing is we're going on the second vector, we're going to place its tail at the tip. So tip to tail, tip to tail, and so on. And that's how you add up all your different vectors. Now, what we're going to need to look at is, let's say we have a force that's pushing this way and then a force that's pushing this way. The thing that vectors are very useful for doing is saying, okay, well, if we have multiple things going on, that's all nice, but what's the total effect? Like, what's the bottom line here? And the bottom line, the technical term for that is called the resultant. And that's basically, what do we get as a result of adding up all of these smaller pieces? To find the resultant is very easy, and I'll show you another example in a different part of the applet here momentarily. You're going to take a vector. Actually, wait a second. Aha! Nope, never mind. We're going to take a vector and place it at the very start, and then we're just going to skip to the end. So we stopped everything back up here. It doesn't want to line up exactly, but you go from your vector from where you started to where you ended your final vector. So if we go up here and then here, that's the same result as if we just gone boom in a straight line there. And again, I apologize, they're not coinciding perfectly, but that's okay, you get the idea. The magnitude of this added up piece, when you're doing this by hand, you can, if you're doing this with a ruler and a pen on a piece of paper, you can simply get your final result by measuring here. Or up here on this tool, we see that the final length of, whoops, here we go. Make sure you have it selected correctly. See how this turned yellow? So vector F, the total of all of our vectors added together, has a magnitude of 25, and its direction is 10.0 degrees, positive 10.0 degrees. And that's really all that there is to adding vectors. Subtracting vectors is the exact same process, except that when you subtract a vector, let's say we wanted to take E, but we wanted to do negative E, so vector D minus E, the magnitude remains unchanged. We simply flip the sign on this. We're going to change this by 180 degrees. So let's try and keep our magnitude as 16, but we're going to change this by 180 degrees. So we're going to add 180 to negative 20, which is 160. And what did we say? We're running out of space up here. But if I could drag it off all the way up here, 16 would be about here. And so our resultant for that would be, something like this. Again, I can't quite pull the arrow all the way off where it needs to be. But that's really all there is to adding and subtracting vectors. You can also multiply vectors. Let me show you that briefly in a different area. Okay, yeah, there we go. So let's say we didn't want to use just vector A, we wanted to use 2A. All you do is you multiply. Or if you're dividing vectors, you simply divide. So if we had 1/2 of A, we would simply take A's magnitude and divide it by 2. Now in the applet here, this is kind of nice. All we can do is see here are the actual measured numbers. But over here we have this simple little equation, dealy bob, where we can change, and now this is 2a, just doubled our original, and you can see the numbers resulting up there. You're going to play around a lot with that in this week's assignments. All right, other key concepts, because this video is already a little bit longer than I wanted it to be for you, ladies and gents. Let's go back here. All right, we're just going to work with one vector. Now, chapter 3.2 of our textbook, that's really all that it focuses on, is how do you add and subtract vectors, and we've been over that graphically. Now, there is a thing called analytical vectors, where basically we're going to have to do a bit more number work in order to combine the vectors. Say there's just some times where we're not going to be able to draw everything out by hand. So what do? Well, what we're going to do is there's a little bit of trigonometry that you can do, but you take your original vector and we're just going to break it down. So we can see that some part of this vector is traveling in the upward direction and some part of it is traveling in the direction of the right. We're going to turn on this guy, and yes, please do show us our values. So the main vector is 14.0. Just the horizontal piece of that, doing a little bit of trigonometry, just with the Pythagorean theorem. I'm sorry, not with the Pythagorean theorem. A little bit of trigonometry, which we're going to skip. The horizontal part of that 14.0 is this 9.9. The vertical part also happens to be 9.9 in this example. But see, these are not always going to be the same. They're almost always going to be different. So as you drag it around, you can see that, okay, this total vector is made up of these little parts. So it's basically vector addition in reverse. Here we have the resultant, and instead of ending with that, we start with that, and we can break it down into its horizontal, or x component, and the vertical, or y component. When we have to add two vectors analytically, really all we're doing is we're breaking it down into the x and y pieces for all vectors. So let's say we've got this. So what would our total vector be? Our total vector would start here and it'd be a direct arrow right up to here. I can put that on the screen, but it would actually just clutter a little bit too much. So I'm going to leave that off for the moment. And let's just talk through how we would do this. It's very simple. Basically, we take all of the horizontal pieces and add them up. And then we take all of the vertical pieces and add them up. So we're going to take this 9.9 and this 15.0, and to get the magnitude, the x component of our resultant, the x component of the resultant is going to be 24.9. Same process with the vertical. We're going to add this y component is 9.9. We're going to add it to 5.5. That's going to give us 14.4. Now to prove to you that that's how it goes, it's not letting me get right there just like before, but you can see we said 14.4, all right, we're 14.5, and it just won't let me quite drag the rest of the way. And 25.1 is pretty close to what we just said it would be, if I could get it all the way to the right spot there. So we can see that it works. You just add up the x's and the y's. Now, if you're going to try and get your total magnitude of the vector from here to here, again, we're not going to go too deep into the math, but what we would do is that piece of math is done with the Pythagorean theorem. Now, I know we haven't talked about that yet in this course, but you'll recognize it from middle school. Pythagorean theorem is c squared equals a squared plus b squared. And we'll talk through a bit more of that in the assignment. All right, I think that's about all. If you have questions, please let me know. Again, we're going to break this down a lot more in this week's assignment, but this gives you the basics of how to work with vectors and combine them in various ways.